Let's look at the substitution method with a definite integral. In other words, how do we deal with these limits of integration here? Well, we proceed with substitution just like usual. I'm going to let u equal x squared plus 1, and then du is equal to 2x dx. Okay, just like usual. Now, I'm going to rewrite the integral in terms of u. So, I've got u to the third du. It just works out simply, right? Because the 2x dx I replaced with du, and then of course I've got u to the third power. Now, here's what you don't want to do. You don't want to put a 1 here and a 2 here. You don't want to do that, because if you do that, what you're saying is that u goes from 1 to 2, but it doesn't. So what we have to do, knowing that x goes from 1 to 2, we have to figure out, okay, well, how does that translate over to what u is doing? Okay, so here we go. We've got x and we've got u. U is x squared plus 1. So let's see here. We're going from 1 to 2 for x, and we want to know, okay, what does that mean for u? Well, let's put a u in here for x, because u is just x squared plus 1, so that's 2 squared plus 1, and that is 5. So we would put a 5 up here. While x is 2, u is 5. Okay? Now let's put a 1 in for the lower limit. So u is equal to 1 squared plus 1, and that's 2. Okay? So we put a 2 in there. There. Now we've got our appropriate limits there for integration. It goes from 2 to 5 instead of from 1 to 2. Because here we were in terms of x. Now our integrand is in terms of u. Okay? So now we can proceed like always. We can say, okay, the antiderivative is going to be 1/4 u to the 4th, and it's going from 2 to 5. Like that. Okay? So let's see what that's going to be. That's going to be 1/4. And this is going to be 5 to the 4th minus 2 to the 4th. There we have it. And we could work that out if we wanted to, but that shows you how we deal with those bounds. Now there's another option to this. We could go ahead, if we didn't want to do this business up here in changing the x's to u's, we could do this. We could say, okay, this is u cubed du, and then we could say x equals 1, x equals 2. And that would do it also. Because if you do it this way, you're saying, okay, these bounds here are not what they're not pertaining to u, they're x. So they're in terms of x. Because if you leave this off, if you don't say x equals, then it's automatically assumed that u is going from 1 to 2. So let's see how that would look. That would be 1/4 u to the 4th, x equals 1 to x equals 2. You have to always carry that along. And now if you're doing it this way, you need to substitute back in. This is 1/4 x squared plus 1 to the 4th. And now we just say 1 to 2, right? Now we're back in terms of x. And if you put that in, look what you get. Look what you have. You have 1/4. Now, if I put in a 2 here for x, I get 2 squared plus 1, that's 5. See? Minus, if I put in a 1, I get a 2. There, like that. Now notice that these two they turn out the same way. There's just two options that you can use.